Hello everyone, welcome back to your own chemistry channel and myself Dr. Mahendra Guleria, Associate Professor in Chemistry. And in this video I am going to discuss very interesting and very important Le-Chatelier principle. And under this principle we study the various factors which affect the state of equilibrium. And there are three main factors which affect the state of equilibrium, that is the change in concentration, temperature and pressure. And in the year 1884, a French chemist Le-Chatelier made a very important generalization to study the effect of change of concentration, temperature and pressure on the state of equilibrium. And that's why this principle is called as Le-Chatelier principle. So now let us define this principle. But before defining this principle, if you have not subscribed my channel, then please do subscribe and also like and share my videos. So let us define. So according to this principle, if a system in equilibrium is subjected to a change in concentration, temperature or pressure, then the equilibrium shifts in the direction that undo the effect of change imposed. And we all are quite familiar with this word undo, because this word is frequently used in computers. And the meaning of this word is reversal of a change. So when the equilibrium is subjected to a change in concentration, temperature or pressure, then the equilibrium shifts in that direction which reverses the effect of the change imposed, and the equilibrium is re-established again. Okay, so now let us discuss the effect of change of concentration on the state of equilibrium. And to explain this, I have considered a general reaction in which A is reacting with B, giving us C and D. So A and B are our reactants and C and D are our products. Okay, and this reaction is at equilibrium. Now if we increase the concentration of the reactants by adding more of A or B, then to undo the effect of this increased concentration, or to reverse the effect of this increased concentration, the equilibrium will shift in that direction in which the concentration of the reactants decrease. Okay, this means that reaction will proceed in the forward direction, because when the reaction goes in forward direction, then the concentration of the reactants decrease and those of products increase. So we can say that the increase in the concentration of the reactants shifts the equilibrium in forward direction, resulting in the decrease in the concentration of reactants and increase in the concentration of products. Likewise, the increase in the concentration of products shifts the equilibrium in the backward direction, because when the equilibrium or the reaction goes in backward direction, then the concentration of the products will decrease and those of reactants will increase, and the effect of this increased concentration of the products will be reversed and the equilibrium will be re-established again. Okay, and this effect of change of concentration on the state of equilibrium can be easily demonstrated in the laboratory with the help of this reaction. Okay, and in this reaction we have taken a solution of ferric nitrate, okay, and aqueous solution of ferric nitrate, and this solution will contain the ferric ions, and to this solution I am going to add the aqueous solution of potassium sulfocyanide, and potassium sulfocyanide is giving us thiocyanate ions, that is SCN negative ions. And these ferric ions are pale yellow in color, whereas these thiocyanate ions are colorless. And when these two ions react, then they result in the formation of a complex ferric sulfocyanide, and this complex is reddish brown in color, and this is the reaction which is taking place here. Now let us suppose that this reaction is at equilibrium, and I increase the concentration of the reactants. I can increase the concentration of ferric ions by adding more ferric salt, and I can also increase the concentration of these thiocyanate ions by adding more potassium sulfocyanide. And when I increase the concentration of these reactants, then it is found that the color of the solution becomes more darker. This means that when we increase the concentration of these reactants, then the equilibrium shifts in the forward direction, resulting in the formation of more and more ferric sulfocyanide, which is reddish brown in color, and the color of the solution becomes darker. So this clearly indicates that the increase in the concentration of reactants shifts the equilibrium in the forward direction. And if we increase the concentration of these ferric sulfocyanide, this ferric sulfocyanide complex, which is the product of this reaction, then we see that the color of the solution becomes lighter. Reason being, when we increase the concentration of the products, then the equilibrium is shifted in the backward direction, resulting in the formation of these ferric ions and thiocyanate ions again, which are lighter in color. So the color of the solution will become less darker or lighter. So this clearly indicates that the increase in the concentration of the products shift the equilibrium in the backward direction. So in this way, we can easily demonstrate to the students the effect of change of concentration on the state of equilibrium in lab. Further, this effect of change of concentration on the state of equilibrium can also be predicted by comparing the equilibrium constant of the reaction with the reaction quotient. Okay, so to explain this, I am considering the same reaction again, and I am writing its equilibrium constant. Okay, so the equilibrium constant of this reaction will be equal to Kc, and it will be equal to the product of that is molar concentration of C into the molar concentration of D divided by the molar concentration of A and molar concentration of B. And these are the equilibrium concentrations of A, B, C and D. Okay. Now, if I increase the concentration of the reactants by adding more A and A or B, then the equilibrium will be disturbed. Okay. Then this ratio will be called as reaction quotient. Okay. So I am writing the reaction quotient, that is QC is equal to concentration of C into concentration of D divided by concentration of A into concentration of B. Okay, but these two expressions are not same, because here we have increased the concentration of the reactants by adding more A or B. Okay, so as we have increased the concentration of reactants A and B, and the A and B are present in the denominator of this expression, okay, then the QC will have less value as compared to Kc. Then for the re-establishment of the equilibrium again, the value of QC will tend to increase until it becomes equal to Kc. And this will happen when the concentration of the reactants decrease and those of products increase. This means that the reaction will proceed in the forward direction, or the equilibrium will be shifted in the forward direction, because the forward reaction results in the decrease in the concentration of reactants and increase in the concentration of products. So this concept also clearly tells us that the increase in the concentration of the reactants shift the equilibrium in the forward direction. But friends, when this value of this QC becomes equal to Kc, it doesn't mean that the concentrations in this expression have become equal to this expression. No. This is because for the ratio of the two terms, here I am considering the product of this C and D as one term and the product of A and B the second term. Okay. So for the ratio of two terms to be same, the two terms need not to be equal. Let us explain. Suppose the value of this term is equal to 6 and the value of this term, that is the product of A and B, is equal to 2. Then the ratio or the equilibrium constant is equal to 3. Okay, and likewise here we can have different concentrations after readjustment. What the ratio, like suppose the value of this term is 12 and here we have 4, then the ratio is equal to 3 again. So the QC has become equal to Kc. Okay, what the concentrations could be different. And we can also understand this concept in a very simple way. Let us consider a balance. So here we have a balance and we have 4 walls in each compartment. It is 1, 2, 3 and 4. And this balance is balanced, which means that it is in the state of equilibrium. Okay, and the ratio of, suppose these are our reactants and these are our products. Okay, so the ratio of the products to the reactant will be equal to 4 divided by 4 equal to 1. Now what I do, I increase the concentration of the reactants by adding more balls in this compartment. So I add 2 balls in this compartment. Okay, now the equilibrium will be disturbed and this compartment will go down and this compartment will move up. And to restore the equilibrium again, what I will do, I will remove one wall from this compartment and I will place that wall in this compartment. Now each compartment is having 5 walls and the equilibrium will be restored again. And if you see the ratio of these walls, you find it is equal to 5 divided by 5 equal to 1. Okay, so we can say that now the walls are not same. Previously we were having 4 walls in each compartment and now we are having 5 walls in each compartment, but the ratio is again equal to 1. That is the QC has become equal to Kc. This is what I mean. Okay, so now let us discuss the effect of removal of products or the decrease in the concentration of products. That what will happen if we decrease the concentration of products. Okay, so we can decrease the concentration of products by removing or C or D from the reaction mixture. And when we remove the C or D from the reaction mixture, then we will have QC, and here the concentration of C and D is less and here it is more. Okay, so here the concentration is less and C and D are present in numerator, so the QC will have less value as compared to Kc. Okay, then for the reattainment of the equilibrium, again the value of QC should increase until it becomes equal to Kc. Okay, and this will happen when the concentration of the C and D will increase and the concentration of A and B decrease. This means that the equilibrium will be shifted in the forward direction in this case also, because when the reaction moves in the forward direction, then the concentration of the reactants decrease and those of products increase. And this concept is very important in industry. Let us explain it with an example. That when ammonia is manufactured in industry with the help of Haber's process, then the reaction involved is this, that is 1 mole of nitrogen gaseous is reacting with 3 moles of hydrogen gaseous, giving us 2 moles of ammonia also in the gaseous state. Okay, and if from this reaction we remove ammonia by liquefying it, that is, ammonia is formed in the gaseous state, and it will be liquefied and it will be removed from the reaction mixture, and in this way we will decrease the concentration of ammonia in the reaction, that is, we are decreasing the concentration of the products, and this will result in the formation of more and more ammonia, because I have explained that when we decrease the concentration of products, then the equilibrium is shifted in the forward direction. Okay, so we will have more ammonia, and in this way the yield of the ammonia will be increased. Another example is the formation of calcium oxide by the decomposition of calcium carbonate. Let us write the reaction. Calcium carbonate decomposes in this way. When we heat it, we get calcium oxide solid plus carbon dioxide gaseous. So we can clearly see here that the carbon dioxide is one of the products and it is gaseous, and if we allow the carbon dioxide to escape from the reaction mixture, then we will decrease the concentration of the products and the equilibrium will be shifted in the forward direction. Okay, and it will result in the more decomposition of calcium carbonate and the more calcium oxide, that is quicklime, will be formed. So in this way this concept is very important and very useful in industry. So I can say here, that is, increase in the concentration of products, increase in concentration of reactants or decrease in concentration of products shifts the equilibrium in the forward direction. Okay, so now let us discuss the effect of increase of concentration of products. So friends, when we increase the concentration of products by adding more of C and D, then the QC will have more value than KC, because C and D are present in numerator of this equation. Okay, and for the re-establishment of equilibrium again, the value of QC should decrease until it becomes equal to KC, and this will happen when the concentration of C and D decrease and concentration of A and B increase. This means that the reaction will move in the backward direction, or the equilibrium will be shifted in the backward direction, because the backward direction results in the decrease in the concentration of products and increase in the concentration of reactants. So from this concept we can infer that increase in the concentration of the products shifts the equilibrium in the backward direction. Okay, and what will happen if we decrease the concentration of reactant by removing A or B from the reaction mixture? So when we remove A or B, then A and B will have less concentration, and A and B are present in denominator, and the QC, the value of the QC will be more than Kc. And for the reattainment of chemical equilibrium, again the value of QC should decrease and it should become equal to Kc again. Okay, and this will happen when the concentration of A and B increase and C and D decrease again. This means that the equilibrium will be shifted in the backward direction, because the backward reaction results in the increase of the concentration of reactants and decrease in the concentration of products. So we can say that the decrease in the concentration of the reactants also shift the reaction in the backward direction. So let us conclude that the increase in the concentration of products or decrease in the concentration of reactants shift the equilibrium in backward direction. Okay, so this is all about the effect of change of concentration on the state of equilibrium, and in my next video I will discuss the effect of change of temperature on the state of equilibrium. So friends, if you have any question regarding this video, then you can leave your questions in the comment box and I will definitely respond to your questions. So please like and share my videos and subscribe my channel. Thank you very much.